Welcome, space explorers, to a deep expedition into the cosmos. Today, we will delve into the cosmic abysses known as black holes, where the laws of physics seem to unravel. Prepare yourselves for a fascinating journey that will take us to the heart of darkness. Black holes are regions in space where matter has condensed so extremely that it created a gravitational field impossible to escape. Not even light can escape from within them, hence they are called black holes. They're invisible to our eyes, but we can detect them by their influence on surrounding elements like gases, dust, and stars. But how do black holes form? The most common origin is the gravitational collapse of highly massive stars that explode into supernovas at the end of their life. When this happens, the star's core contracts so much that it becomes an infinitely dense point called a singularity. This point is surrounded by a point of no return, called the event horizon. Anything crossing this boundary is swallowed by the black hole, with no chance of return. There are different types of black holes based on their size and mass. The smallest ones are stellar black holes, ranging from 3 to 100 times the mass of our Sun. They are the most common in the universe and are usually seen orbiting other stars or even other black holes. The largest ones are supermassive black holes, with millions or billions of times the Sun's mass. They are found at the centers of galaxies, including our Milky Way. The origin of these giants is still a mystery to science. Between these extremes, there are intermediate black holes, with hundreds or thousands of times the Sun's mass. They are the rarest and most challenging to observe. Black holes are incredible objects that defy the laws of physics and our understanding. They were predicted by Albert Einstein's general theory of relativity, which describes how gravity affects space and time. According to this theory, black holes distort the space around them, creating effects like gravitational lensing, which magnifies the image of distant objects. They also dilate time, causing it to pass more slowly near them than far away. However, Einstein's theory is not the only one attempting to explain black holes. Physicist Stephen Hawking proposed that they are not entirely black but emit very faint radiation, named after him. This radiation would result from the creation of particle pairs at the edge of the event horizon, with one escaping and the other captured by the black hole. This would cause the black hole to lose mass and energy, potentially evaporating completely. This idea raises an intriguing question. What happens to the information contained in the matter that falls into the black hole? Is it destroyed or preserved? This is one of the greatest controversies in modern physics, known as the information paradox. So, what happens if you fall into a black hole? Well, it depends on the size of the black hole. If it's very large, you might pass through the event horizon without feeling anything different. But as you approach the singularity, gravity increases so much that you are stretched and torn apart in a process called spaghettification. If it's very small, you won't even enter the event horizon, as you'll be vaporized by Hawking radiation. Either way, your fate is fatal and irreversible. But don't worry, as black holes are not world-devouring monsters. They only attract what is very close to them and do not have more gravity than the objects they originated from. In fact, they are essential for the formation and evolution of galaxies, stars, and life. They are also sources of knowledge and inspiration for science and art. Undoubtedly, they are one of the wonders of the universe. I hope you enjoyed this video about black holes. If you did, please give it a like, share it with your friends, and subscribe to our channel.